Alright, Trig and Pre-Calc, we are back with another review video. We've got another system of equations with three variables here. And this one is something that we got to get used to, not having any equations with a x coefficient of 1. So there's nothing that's super easy to scale right here, nothing that pops out at us where we can reduce that coefficient down. So this is what we're just going to have to deal with right now. But something that I do see, looking at this right away, is that since we're trying to eliminate the x variables first, negative 4 and 8 can easily cancel each other out if we multiply this middle equation by 2. So that's going to be my first step. I'm going to multiply that equation by 2, and that way we can get these two terms to be opposites. So I'm going to rewrite my equation. After multiplying the middle row by 2, okay, and this is what we're left with there. So now we've got negative 8x minus 6y minus 12z equals negative 20. And now this is where we can eliminate one of the variables already, which is great, by adding r2, not r1, like I wrote. By adding r2, and then we'll rewrite the system equations again to get these two variables and coefficients cancel out, so these two terms are gone, and we are left with negative 3y plus negative 6y, negative 9y, and negative 12z plus 2z is negative 10z, and that is all equal to negative 18. I think I did that right. Yep. Okay. So now that we're here, another thing I see is that since we're going to try and eliminate this x value, it looks like there's another, or the other x value can be easily multiplied, and then we're going to have to flip the sign, but we could change this one so that these two are opposites again, and we can get rid of the middle row's x term. So in order to do that, we're going to have to multiply the top equation by negative 4, otherwise we would have to divide the middle equation by 4, and we don't want to do that because not all of those terms are divisible, or easily divisible. So what we'll do is we will multiply by negative 4, and I'm going to rewrite that down here. So we'll move over here. So negative 2x times negative 4 is 8x plus 12y. Actually, that's minus 12y plus 16z equals negative 16. And then the middle row stays the same. Negative 8x minus 6y minus 12z equals negative 20. Negative 9y minus 10z equals negative 18. So this one didn't change either. And now we see that once we add r1 to r2, we can get rid of, sorry, I'll step in the frame again. Once we add r1 to r2, we can get rid of this negative 8x, and then we will be left with only one x variable, which is exactly what we want in row echelon form. So, like I said, we will add R1. We'll rewrite our system. So we've got 8x minus 12y plus 16z equals negative 16. And then once we add R1, we're left with 0 here, and we have negative 18y plus 4z equals negative 36. And then we've got still this down below. Row 3 doesn't change, so we have negative 9y minus 10z equals negative 18. So something I'm going to do to this equation real quick is I'm going to divide this whole thing by 2, because it looks like this y term is half of this y term, and this solution, or this total, is half of this total. So what I'm going to do is I'm going to divide this by 2. And to signify that I'm dividing this by 2, I'm going to erase everything and rewrite it in red so that you can follow along right here. So negative 36 becomes negative 18. And actually we'll divide by negative 2 so that we can make these opposites and cancel them out. So that's going to be a regular 18. And this is going to be a negative 2z, because we're going to multiply it by negative 1/2. And then this one is going to be a 9y. So after we divided the middle row by negative 2, we're left with 9y minus 2z equals 18. And then row 3 is negative 9y minus 10z equals negative 18. So this one, very easy to eliminate this y term here. Just going to add R2, and that'll give us and actually on the way over I'm going to divide this top row by 4 so that we have a simpler equation. So we have 2x minus 3y plus 4z equals negative 4. And the second row stays the same. 9y minus 2z equals 18. And in the bottom row, we lose the negative 9y, and we're left with negative 12z equals 0. So once we're here, we can easily solve for z. If you can see what that is. We can easily solve for z because 0 divided by negative 12 is obviously 0. Any number that, anytime, or there's no other number that's equal, where negative 12 times that number is 0. So we know, I'll write it down here in our little solution box. We know that z is going to be 0. So if z equals 0, we can plug 0 in for z right here. And we know that 9y minus 2 times 0 equals 18 can just be rewritten as 9y equals 18. Divide both sides by 9. We'll see that y equals 2. So we'll put 2 into our solution. And now that we have 0 and 2, we can plug that into our top equation to find x. So we have 2x minus 3 by 2 plus 4 times 0 equals negative 4. If we solve for that, we have 2x minus 6 equals negative 4, add 6 to both sides. We get 2x equals 2, so x is equal to 1. So there's our solution to this equation. I'll step out of the way. Y'all can screenshot or copy it down if you need to. But like I said, there wasn't a super easy way to start, but something that I noticed first of all was that these were easily multipliable to eliminate each other, and then everything else just kind of fell into place from there. So just keep the 3 methods of elimination in mind, and yeah, critically think about where you're trying to go with the equation, what the solution is going to look like, and how you get there.